Okay. Let me share my screen too. It's good now. Can you see my screen?
Yes.
Okay.
Yes.
Okay, that's good. Okay, recording started. Okay, let me start it. Okay, so like Agile, there is another framework is called DevOps. DevOps is a buzzword. It is pretty much, you when we go to, when we join a job in whatever role it is, you keep hearing this word. So my main focus of teaching all those concepts is, to give you an idea, what are the current day trends when we hit the job market, and what are the frameworks they are using. So one of the main thing is DevOps. So what is DevOps? So if you see that, right, earlier we all know that, right? So this one, if you see this software development like life cycle, we know that, right? So there is a requirement gathering. Once we gather all the requirements from our client, see, if we have the development company, let us assume all of us, we belong to one software company, right? So if we support a if we support a client, let us say, same example, client like Macy's. So we are developing software for Macy's. Macy's is our client. So we belong to a software company called C. So our company C develops product for Macy's. So first what we have to do, we have to gather the requirements. Then we do the designing, because the requirement to design phase, we will it's all phases, right? Different phases designing. Once the designing is over, then the implementation and coding. And once we are done with the coding, the testing part. Once testing is done, deployment. After deployment, if there are any minor issues, that will goes under the maintenance part. So this is what we have been talking about it, right? STLC. So STLC, we talk about it, and even we know this is Scrum, right? Scrum is, it's like a more agile, more flexible, more collaborative environment than a regular, a conventional waterfall. So if the product is like really, we don't know all the requirements, but we know whatever requirements are available, we pick them up, and product backlog. Then we will go for the sprint meetings. Then we have all the sprint backlog, then sprints, and we know that, right? Sprints. Then we have daily Scrum meetings, and once all the sprint is over, sprint review and sprint retrospective. And after that, we will pick up the next set of backlog items from the product backlog, and again we will start the next sprint. So it's on and on, right? Until we are done with all the product backlog, or until the client is happy with whatever he has. He said that, oh, enough sprint enough sprints, we are happy with whatever we have, let us stop it here. So actually, who will take the call? Always the customer is the boss, right? Because he is sponsoring the program and he is paying for it. So we are providing service to him. So if you see this STLC, or if you see the Scrum, these are all frameworks. I mean, STLC is a process, but Scrum is like a framework. So similarly, this is the DevOps. Now you know that developers, they're part of planning, they're part of coding, they're part of building the software. And once they're done with the software, what we do? We do the testing. So that's why he put like the bug, to find all the bugs here. And once they're done with that, what they will do? They will deploy the code. So similarly, if you take any software company, it's not only a development team. There are like multiple teams. That's what I have been telling, right? So we are not trying. We are there are tons of jobs, variety of jobs. There are different categories of jobs there in the job market. There is no particular jobs. If somebody is good at the coding, they can go as a developer. That's good. But there are other jobs also there. There is a business analyst jobs, project management, Scrum master. Not only that, to maintain the infrastructure for the organization. What are infrastructure? Like, servers. If we deploy any software, right? If we deploy any software, we need to deploy on a server, like our computer. We want to run a program, or we want to do something, we want to do purchasing, whatever it is. What we do, we use our computer, right? So similarly, when they want to deploy any program, they need infrastructure, that is like machines, computer. So for that one, there is a different team that is called operational team. So The developers, they develop the product, they get the requirement, they code, build, deploy it, right? That is development people do. But once they develop the code, make sure that the websites are up, there won't be any security threats, and make sure that is a smooth operation, smooth process of the transactions, especially during this peak hours, right? Like our Thanksgiving or Thanksgiving time, or Cyber Monday, right? Many of the websites are down actually. Why? Because the load, especially during this time, right? There is a tons of load, right? So if they design the infrastructure software good enough for um, certain number of transactions, right? But what happened during this holiday time? So they see huge volumes or huge, you know, hike, there is a huge bumps, it's like a huge increase of the volumes. And if they don't properly plan their infrastructure, so the website is not available, the system is not, website can be down, it cannot handle that many transactions. So these things comes under operations. So there is a two, we are talking about two paradigms. One is like a development paradigm, second thing is operational. Operationals comes under security, monitoring, and maintaining infrastructure. So all these operations come under operations. So dev and operations. These two world, if they can collaborate and work together, that is pretty much like DevOps. DevOps have a tons of definitions. Every definition depends on their perspective, particular perspective. But in overall, let's not get confused at this point. The more and more we dig into that, right? So we will get better clarity. So at this point, let us think about it. It's like two paradigms, they work together: development world and operational world. They work together, they integrate. That is pretty much like the DevOps. So similarly, we discuss about project management. There is a plan, risk control team, goals, budget, right? Whatnot, right? We discuss in our project management. Similarly, this is, so there is a certain concepts on DevOps. We are going to learn all of them. So if you see that, right, DevOps, pretty much same thing, same software company, same set of employees, same kind of category of people, that it's a different methodology for a better organizing the product, or better organizing the development process, or better organizing their operationals. So as the time progress, right? So we are, in the market, we see a lot of new frameworks or new concepts. So which is for even, to betterment, further betterment, right? So earlier when I joined in the industry like 20 years ago, there was just like waterfall. So waterfalls, but now you see that, right? Everything is like agile. Everything is like a DevOps model. So everything, there is a much degree of collaboration. So this is all to improve the software productivity. At the end, it is for the betterment of the company, and it is for the betterment of the people who work in the IT industry. So if you see that, right, DevOps, coding, let us take from coding. Coding, when you do the code, once the coding is done, we do the deployment, right? Now, I mean, before we do the deployment, we compile the code. There is something called we build the code. And any programming is language, right? Like a Java or Python or any language. Once you develop any product, what they will do, they will build an artifact that is called artifact. Artifacts are in general like war file, war, jar, ER file. Those are like artifacts. They will take a bare metal code and do the compilation, and they will package all of them, and that is called build. Once the build is ready, they won't directly deploy into the production. What they will do, they will do the testing, make sure that it will pass all the test cases. So once they're done with that, it's like again package, right? Package. It's a build, test, and package. Then they release to the production and operate. It's operational. Then it's like a monitoring. Make sure that it's not breaking any system parameters. It's not breaking any system resources. And again, planning. Same thing. Planning, coding, building, test, package, release, operational, monitor. If you see that, it's like a cycle. DevOps cycle. So now you see that, right? How many parties involved in this one? Coding, development world, build, build. This is like a DevOps engineer. They do that. As site reliability engineers. Site reliability engineers comes here. But package testing again, QA team, and packaging, releasing, operating, and monitoring. There is like another infosec and monitoring team generally that takes care of it. And again, planning. The planning again, project managers, business analysts. So there are like multiple parties. It is like a collaboration between in several parties. That is called DevOps. So let's see. Let's go here. Okay, so DevOps reference architecture, project team. As I told you, right here, I told about the different stages or different parts of it, right? But now I'm talking in a um, individual teams perspective. See, again, project management team, they do the planning, software development workflow, and governance and compliance. I'm going to talk about it. Automated monitoring and development scripts, issue tracking, and source control, environment management, continuous integration, test automation. I'm going to talk about all of them. Okay. If you don't get it, don't worry about it, because we are going to repeat some of these concepts again and again. Okay, Shraddha is here. Okay, let's see. So yeah, software development, governance, and compliance. See, nowadays, companies are very strict on the governance rules. What are governance rules? So if you work on any healthcare product, we not only we have to make sure that we don't expose any user data to the outside world, because there are a lot of regulations in especially in US, Europe. There are a lot of regulations. When we provide any service to the any customer, we make sure that we guarantee their privacy. So even accidentally, if you expose their data, private data, personal data, right? So that is a big security threat to the company. And even some companies, they went into bankruptcy because of this kind of thing. Even when we, any financial transaction companies, like a credit card transaction companies, they need to be really careful whatever customer information they're storing. Make sure that it should not be compromised. So for that one, there are a lot of guidelines. Government set up a lot of guidelines. Even industry standards set up a lot of guidelines. Those are called governance and compliance. See, there are two things, right? Developing a product is different thing, but make sure that that product won't do any bad other than doing good, right? So that is important too. So if you see this, we talk about virus programs, right? Virus. Yeah, we got like a ransomware, we got a malware, we have a lot of software. We talk about a lot of virus programs, right? Virus programs themselves are software products. They're software products. They're well structured, well defined, and well developed software products. But their purpose is different, right? Their purpose is to do some malicious activity or a bad activity, right? Those are not good players, those are bad players. Similarly, we make sure that our software product won't do anything damage to the organization or to the customers. Make sure that it won't breach their faith, right? So for that one, we have to set up this lot of governance and compliance rules. The next one is automated monitoring. So nowadays, if you see in the IT industry, right, a lot of manual steps are getting automated. The main purpose is automation eliminates a lot of repetitions and mundane tasks, so that it eliminates them, so that people can focus on a bigger challenging tasks. And we are all human, right? There is a possibility of error and mistakes if you keep doing everything manually. So but if you automate it, so there are pretty good automated, right? If you well define the rules, if you set the well defined automated rules, so there are pretty good chances that it will go through. So but we can keep adding more automation scripts, or more automated principles based on the requirement. So issue tracking, if there are any issues, we have to keep track of them. There are development scripts and source control. So I'm going to talk about source control. See, if our company C, if the company C has let us say 50 developers, if company C has a 50 developers, so they develop the product, right? They do the coding. Okay, if developer A develops a code, if developer B develops a code, right, where they will, okay, once they're done with the development, where they will store those code. So if I keep my code on my local machine, if somebody keeps their code on their local machine, so it won't work, right? Because see, in the big companies, what they will do, they will divide the work. So if the developers 50, they will divide their work into different modules, and people work on their individual modules. And whenever it is needed, they will collaborate with the rest of the team members. So, but once I'm done with my code, what I have to do? I have to integrate with the rest of their code. So how do I integrate with that? That is called continuous integration. We integrate individual code blocks into a big code base. Let us assume like a Legos, right? Individual blocks, whatever individual blocks we have it, we have to join together to get a final product. Pretty much the same here. Continuous integration, same here. Considering this agile methodology now, so the software development process became like so rapid, so quick. So that's why, so people don't wait like a weeks or days or months to integrate their code with the rest of the team code. So nowadays code is like you develop the code and you check in. Check in, you mean you integrate your code with the rest of the code. So it per day, if you take a day, they integrate their code like n number of times. I mean, depends on the requirement. If the developer is working on one change, he will work on that change, he will work on that issue, or he will work on the development module, whatever he committed for, and check in the code. Check in the code is like, he integrate the code. There are a lot of integration tools in the market. Those are like a GitHub, Subversion. There are like multiple tools in the market, but we will talk about the tools later. Just at this point, I'm trying to give you an idea about the overall architecture. So that is like a code integration. So there are two buzzwords we hear a lot. One is DevOps, and second thing is CI/CD. CI mean continuous integration, CI continuous integration, CD continuous deployment. CI/CD, CI/CD. We keep hearing this word CI/CD or DevOps. So that is what CI mean continuous integration mean the developers individual blocks, they will integrate the code continuously. That is continuous integration. Continuous deployment. Continuous deployment. See, for example, Facebook. If I post something on the Facebook, I don't wait for the, I don't wait for the until tomorrow, right? To get it posted, right? So you don't have to answer, but when you post something on the Facebook and it won't appear in less than a minute, how do you feel? So irritated, right? So because see, that's what our expectations, user expectations, and even companies, they know that user expectations, and there is a lot of competition going on. That's why they always trying to be on top of it. So what?
So, Raviji, this is called the acceptance criteria also, right? I mean, we can add these things
Yeah, we can
into
add that in the add that. Yeah, add this in the acceptance criteria when the final product is over. So when we have the meeting with the the stakeholder, right? In this case, Macy's, right? So stakeholder actually. So it's not only a delivering a product, but delivering the product in certain parameters, right? There should be the response time. The response to time should be quick enough. The latency, the time delays should be less. There are all comes under factor actually. So for the acceptance, what they will do, they will set up a acceptance criteria when you develop, in the agreement itself, right? When they put the agreement, right? So when you deliver the final product, your product should meet this criteria 1, 2, 3, 4, 5, something like that, right? So that is yeah, that can come under the speed also should come under that.
So yeah, it's all like non-functional requirements, right?
Yeah,
Yeah, yeah.
yeah.
I was
So
just confirming.
oh yeah, yeah, no
Okay,
worries. Yeah, yeah,
thank you.
that's good. You're welcome. Yeah. So the thing is here, the continuous deployment means, see, like the Facebook. So whenever we post something, so it will be posted there, right? So that is actually production deployment. When we post something, when I post, let us assume I post a picture, behind the scene, it triggers the process so that it will be reflected. My change will be reflected. Whatever I posted, it will be reflected in my page, right? It won't go somewhere else, right? So this is all actually integrated system. So whatever I trigger the process, whatever I do the process, it automatically deployed. That is a continuous deployment. So the deployment happens in the live production environment continuously. So nowadays, earlier there was a process called monolithic. There was like a big software for the whole organization, like or few big software products. But nowadays people are following a different concept called microservices. I will share about it after a few slides. Okay. So let's proceed further. And anyway, we are going to revisit all of them again. And I took some of these concepts from the book, whatever I share, and some of the concepts, they're not from the book. Those are from outside. So I know that you guys are already diligently going through that book. So I feel like I should add more value, by bringing in more generic examples, so that will be helpful. That will be helpful along with the book. That's what I got some of them. So if you see that, right, in the DevOps world, we have like a multiple phases, like a coding, we have planning, we have release, deployment, operate, monitor, test. It's from the same concept here. From here, whatever we brought it here, this is what I'm sharing. So if you see them, right, there are like multiple products to see. DevOps is not like a particular technology. DevOps is not like one concept, right? It has like a multiple, right? So for the deployment, we use Docker. Docker is pretty what is that? That is really good technology. Technology in much demand now. And operate, we have like a Chef, Ansible. Ansible is good to Kubernetes and monitoring. Don't worry about it. Just giving an example. Whatever is needed, that's what we learn, right? To monitor this one, we use the Splunk. We have like a Datadog, and Nagios. We use Nagios. Jenkins to do any builds. I will explain what is build after a few slides. So Jenkins, we will revisit this slide anyway. So here Selenium, and we have the JUnit Maven. Yeah. So these are all multiple tools available uh, in this DevOps world. So DevOps, again, continuous business planning, collaborative development, continuous testing, continuous release and deployment, continuous monitoring, collaborative customer feedback, and optimization. So current IT industry, pretty much they revolves around this one. DevOps is a collaborative. It's a much collaborative. At the end of the day, what is our main purpose? Whether it is Agile, whether it is a DevOps, our main focus is better degree of collaboration, right? Better degree of collaboration within the organization. So this is a continuously business planning. So it's not like, the business guys, they get the requirement one time, they don't, they will just chill out, right? It won't work. So it is like a continuous process. They get the first module and it will go for the next phase. And again, they will keep working on the next phase, next phase, next phase. It's like continuously development, collaborative environment, continuous testing, continuous release, continuous collaborative feedback and optimizing. So time to time, they regularly get the feedback, and wherever it is needed to be improved, they will work on the improvement of the process. So that is the beauty of the DevOps. You see that there is so all these phases, or maybe all the partnering teams, they collaborate pretty well. So that is the main purpose of DevOps. So if you see that, right, Toyota improvement kata, Toyota work on a project actually. So see, all these companies, time to time, they invest a lot of time to come up with the new methodologies which can help them to improve the productivity. That's what they do. So Toyota improvement kata, to use a Toyota improvement kata as a routine to move from current situation to new situation, a creative directive. So there are different ways, actually. There are different phases. In the book, you will see few details of it. First, there are like 4 phases actually. So Toyota work on a project actually. They came up with a few concepts actually. So understand the direct challenge, grasp the current conditions, establish the next target condition, experiment towards the target condition. Because um, first of all, understand your base, where you are, right? So understand the current base where we are, and understand the current challenges. Then we target for the next target. But sometimes in the software industry, particularly in the Agile, right? So when all the requirements are not ready yet in the beginning itself, the more, the more and more you work on it, the new requirements will come up. The more they understand the system, new requirements will come up. So that's why in the Agile methodology, what they do, They won't wait until all the requirements are ready. They will start the development process, whatever requirements are ready. So they keep coming actually. The new requirements will show up, and either the product owner will keep talking to the stakeholder and keep getting the new requirements and start working on it. Here also, first of all, understand our base, where we are, and what are the current challenges, and what are the current conditions, or what are the current constraints. So once you know that, then you target for the next condition, next target. So from our current condition to the next conditions, pretty much it is like an experiment. Experiment, you know most of the details well, and you don't know some of the details well. So it is pretty much like when you are executing a new arena, when you're executing a new functionality or a new product, there might be surprises. That's what will we do once we are done with all of them. Again, there will be a planning. Again, there will be collaboration, right? Make sure that the product is good and well documentation. So this is a generic one, don't worry about it. So Toyota did some project, and they came up with 4 different phases actually, phasing planning. Understand the current challenges, current conditions, next target, and experimenting towards the target. And it's like a cycle. It's go again and again and again until they are okay with achieving any product. So chronic conflict between development and operations. So everything looks really good, right? But in the companies, in the real world, there is a pretty possibility of a conflict between different parties. See, because when you see that, right, it's like a really a fast-paced environment. So everybody is they work on their particular role business, right? So make sure that collaboration is good. But wherever there is a collaboration, there is a chance of misunderstanding. There is a chance of tensions, right? So that's why, see, development team has quick delivery to respond changing demand. So that is their responsible. Development team get the requirement, do the development, and deliver it. So that is their main focus. So operational team has to guarantee that the environment is stable, predictable, and secure. So they have their main focus. These people have their main focus, but they have a common functionality. They have like a common interest. So where there is a common interest, we have to make sure that there won't be any conflicting. So now you are in the technical debt. Okay. Continuous firefighting, workarounds, and unplanned activities. So with result. Okay. Okay. DevOps world, what happened? As we discussed, right? Wherever there is a collaboration, there is a chance of firefighting. If there is like a product manager or a scrum master or somebody, what is the role? Scrum master make sure that impediments, right? Removing impediments. The impediments can be not only technical challenges, right? Sometimes because of just people. If the people stressed out, and if there is if there is some kind of misunderstanding, right? Then the scrum master jumps in, or the project manager will go, or somebody, somebody in the organization has to do that. In the DevOps, as there is a much degree of collaboration, make sure that there will be smooth collaboration between multiple parties. That's what he was trying to say. Not only impact the performance of our, see, for example, let me read it out. Continuous firefighting, workaround, and unplanned activities to save your day will only result in accumulation of more technical debt. I will explain what is technical debt. This not only impacts the performance of your development and operations, but also negatively impacts all other units, including your architecture, information security, testing, product management, release management. Sometimes you see, right, in the organization, the QA team, and there may be some tensions between QA team and development team. So is it good? No, right? At the end of the day, everyone works for the same organization. If the QA team ignores, okay, yeah, we don't care, if they ignore like few bugs, if they surface out sometime in the later, so that will add a lot of, lot of technical debt. Technical debt means the amount of work we need to do, the amount of technical work we need to do. So if there is no proper collaboration, what happen? There are few bits and pieces, they slip through the cracks. So what happened? If they miss few details because of lack of proper collaboration, what happened? If the designing phase, if they don't design properly, or the coding phase, if they don't code properly, if they surface out later point, Then again, they have to do a lot of work, right? Again, they have to, somebody has to open a bugs, and there is a lot of work around. There is a lot of work needs to be done. So that is called technical debt. Technical debt is pretty much the amount of technical work or amount of work needs to be done. Or the more and more the collaboration is not good. So obviously, you see a lot of gaps in between any phase of the development. So that result in redo of the work. Again, redo of the planning. Again, redo of the coding. Redo testing. Make sure that we don't break anything. Unnecessary lot of work actually. Rework. Unnecessarily, we have to do a lot of work actually. So that is called pretty much like technical debt. Technical debt is like several meanings. One is like redo of the work. Second thing is technically, if company is using, company is going in a certain direction technically, right? But when we lag behind, right? If they are not, company is not investing their resources on educating or empowering their workforce, right? What happened? The company requirements, technically company requirements is somewhere, and the workforce technical background or their technical capability to handle that work is somewhere. So in between this, there is a lot of difference, right? There is a lot of, you know, there is a lot of difference. I mean, there is a lot of gap. Let me use the other word, like a lot of gap. So then it will become so difficult, right? So that is another word, technical debt or technical debt. The more and more, if there is the collaboration is not so good, there will be a lot of points. There is, there will be a lot of redo work. So that's why conflicting between development and operation. DevOps, one of the main concept is not only technical, but also it involves a lot of conflicting parties or lot of collaborating parties. So they make sure that we have to bring everyone on board. And one more thing is DevOps highly performance play a different league, and they manage increase average number of code. Okay, yeah, that's what I say. See, for example, here, see, let me read one more. DevOps high performers like such as Google, Amazon, Facebook, Netflix, and Apple have already proven that there is a possibility. Yep. Earlier companies, when it was a waterfall, they get all the requirements, they develop the code and do the deployment once in a month, maybe twice a month. But in this agile or in this fast-paced development, right? Especially like a Facebook. Facebook, every time when we post something, that is a deployment. Netflix, when we watch something, that is a deployment. When we do something, Amazon, when we put a order, when we put a order on the Amazon, that is a deployment. When we put an order, it automatically triggers an action in the Amazon. It automatically reflects there. Then we will get the tracking number. We get all this number. That is all deployments behind the scene. It all happen. So when we Google, when we use the Google email, Gmail, or Google search, anything, everything causes an action behind their software. We don't see that. We're just end users, right? So just we use them. So these are all like a number of deployments they do every day, they do every minute, they do. So that's why most of the successful companies, what they did, from waterfall to they came this far. What they do a number of deployments, they do a lot of deployments for the success of their companies. Number of code deployments per day for a developer. So you see there are a number of deployments are growing. So if you see this, let me highlight it a little bit. Most of the high performance companies, they have like a maximum number of deployments. Some of the high performance companies are like Amazon, Facebook, Netflix, or Google. So the number of deployments, the number of deployments grow with their success. So companies are not afraid of doing like multiple deployments, number of deployments now, because there are a lot of tools available, a lot of methodologies available, a lot of technically strong workforce is available. That's why now they're not worrying about it. So for example, what is, see, high performance DevOps organization, 46 times more frequent code deployments, 440 times faster lead time from commit to deploy. You see that there are like times 46 times, 96 times faster than mean to recover this downtime. So the yeah, so these are all, if you see that, right, the number of deployments increased, so improved the productivity and throughput, improve improve the code and operational liability, improved organizational performance and client satisfaction, improved market penetration, market share, and profitability. Soumya, you asked the question, right? So now there is a lot of competition, right? So for every product, in the market there are a lot of options. So the speed and the latency, less latency, these are all factors actually. If one customer is not offering, right, they will go for other customer. So there is a lot of competition in the market. So every single parameter is valuable. That's why the DevOps model, it brings all the parties of a company together to achieve a common goal for the success of their particular organization. So all these statistics you can read in the book. Just I drop it here just to give you a quick comparison. So just want to give like a little idea about what are the deployments, number of deployments. So that's why you might ask me like so we are all going step by step. Agile, we know that Agile is like a flexible methodology, flexible framework which can collaborate and cooperate a number of deployments, multiple number of deployments in a very collaborative environment instead of stepping on each other toes, right? So that's what. So now it is.
So we can say that you are saying no that so many companies are offering different things. So we can say this is kind of.
Sorry, what is that? Can you say it again? Soumya, can you say it again? Sorry. Can you hear me? Hello,
Yeah,
Soumya?
we can hear you, but Soumya, we lost her.
Okay, okay. Okay. Soumya, you can ask that question when you are back, okay? Are you there?
Hello, am I audible?
Now, yeah, please. Yeah.
So did I break my voice? I don't know whether you listen.
Keep talking. I mean, can you say it again? I lost that actually. We lost actually.
The
Yeah.
thing is, like you were saying, like these are the things, like it seems to be like a parameter how the company is judging the product, like which is better, which is not, like all these things, the latency rate and the reliability, the
Throughput. Yeah.
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 So this is kind of like they are deciding which is better, which is not.
Yeah. I mean, these are all the the result of a better collaborative work environment, either through the Agile or a DevOps framework. But the end, the main purpose of the organization is to achieve these goals, right?
Oh,
Because
okay, yeah,
yeah,
got.
yeah,
See,
because there
as
is a lot
a
of yeah,
developer point of view, right? Yeah, got.
yeah, yeah. So,
Yeah, yeah.
I mean, these are all I'm talking about all these, talking out loud, right? So why this is all benefits of using the DevOps. Just like overall, what is the DevOps architecture? Like what are the parties involving in the DevOps, and what is
Okay.
the degree of collaboration between the parties, and what is the end goal of it, and what are the challenges, or what are the parameters, or some of the companies which are very popular and we know in our day-to-day life, right? So what they achieved out of this DevOps kind of mechanism. Yeah, these are all just we are talking about in general about the DevOps framework kind of thing. Yeah.
For sure. Thank you so much. Thank
You're
you.
welcome. You're welcome. Yeah. So it is not easy. It is not an easy task to drive an organization IT transformation. DevOps is no exception. However, by starting small, you won't be taking much risk. On the other hand, never forget this is one more profound duties of any younger. Okay, let me tell about it. See, DevOps is not only technical, but it's a cultural paradigm shift. Generally, people more in a human tendency, right? So generally, human tendency is hey, leave me alone, let me do my job, right? Wherever it is. So that's what generally human tendency, even in the IT companies also. Nobody wants to be told repeatedly, right? Nobody wants to be not many people like to be in the limelight. They're like, hey, give me the work, okay, I will give you back the result, leave me alone kind of thing. But it's not going to work out for the, like, especially like the methodology like a DevOps. You have to bring everyone on board. There should be much degree of collaboration, like our Agile. If you put everyone in the Scrum room and everyone do their own work, right, what kind of Scrum that is Scrum called, right? Scrum itself is the main intention of Scrum is a better collaboration. The main intention of DevOps is to bring development, operational, and QA, and infrastructure, information security, and all these parties together for a better collaboration. So when you bring that many number of people, right, obviously there will be some friction, right? So what we have to do, we have to talk to the people. We have to, there is a much degree of um, you know um, to bring everyone on board. So one example is when I joined one company, my previous company. So people were not using this code integration. When developer develop the code, they have to, they're supposed to check in the code immediately, make sure that their code is integrated with rest of their code. But many developers they were keeping their code in their local machines. If developer keeps their code on the local machine, if it is not integrated well, do you think the system, do you think the company is running in a very successful model? Definitely no. Because all of a sudden, if they decided to integrate the code, there may be bugs. There may be, they might be missing the latest version. They might be integrating their older version. They might be using some older code. There may be integration. During the integration, there may be some conflicting, merging. There may be conflicting, integration process, right? So it's not good at all. So they were not using, definitely they were not using the DevOps model. DevOps model encourages a continuous integration continuously. Whenever you build a even small bit of code, small blocks of code, once you are done, just integrate the code. Make sure that your code integrates with the rest of the developer's code, right? So it was clearly failing, that one. But to bring everyone from whatever they were doing to what they're supposed to do, it took a really good amount of time. There were multiple meetings with their managers, multiple meetings with their executive team to bring everyone on board. So DevOps is a big cultural shift, actually, because people are pretty comfortable working in silos, but then you have to bring everyone on board, make sure that they follow certain norms, so that they play fair, with a better collaboration. So that's why here the author said that, right? It is not easy to task to drive an organization into IT transformation. Any transformation, people, that is a natural tendency. People resist the change. So you have to bring everyone on board. Main, it involves a lot of dialects. But once you get everyone on board, once once people get used to this DevOps model, you start seeing the fruits of it. Any organization, there is no exception. So any organization is like that. In my previous organization also, people initially resisted. People initially, uh, they have their fears. Oh yeah, you guys are automating everything. We might lose the job. Or if you if you integrate the code, if you do the deployments automatically, if you do the testing automatically, so what will I do? There is some insecurities, or maybe oh, there may be a lot of learning curve. I might have to learn all these new tools. Already I have a lot of work, then why would I have to go through this you know n number of tools learning? There is a resistance, right? It's a human tendency. It's a friction inside our body, right? So there is a lot of fears, a lot of it all comes with a lot of dialogue. So then, after all, there are benefits. Significant improvement of the product quality because much degree of collaboration. And not only that, and we start addressing all the topics, not with much technical debt. I mean, we start addressing almost all the challenges in the beginning itself. We are not going to wait until it really overgrow and it will come back and bite us, right? So code, when they are developing the code, small blocks, we are encouraging them to integrate. So that is called significant improvement in the product quality, improve the performance of the software, minimal cost production, because we are not doing we are not encouraging the redo work. Just we are encouraging the work go like very smooth and with much collaboration, so that there we won't leave much scope for errors or redo work. So reliable infrastructure managed by coding, faster problem solving abilities, faster deployments, improvement of the productivity of the organization. At the end, what happened? Improvement in the productivity of the whole organization. Organization is nothing but individual teams, right? So if every team collaborate well, if they start developing the product, yeah, in a systematic way, right? Obviously, at the end, the result is it improve the productivity of the organization. These are the 7 key benefits of the develops. There's a lot of chaos. There is a lot of collaboration. There is a lot of different principles. So, but the end, it all improved the productivity. And DevOps roles. We talked about the Scrum roles earlier, right? Similarly, DevOps also, there are some main roles. Let's talk about it. There is a product owner. Our friend product owner is here too. Like our Scrum, the product owner talks, product owner talks to the stakeholder and get all the, stakeholders requirement, right? So our company C product owner will go and talk to Macy's guys and get all the requirements. That is a product owner. And second thing is the team lead and cloud architect. Cloud architect is pretty much now infrastructure is like infrastructure. Everything is like a cloud, right? So there is a cloud architect and the site reliability engineer. Site reliability engineers, when we do the deploy production, when we do the deployments in the production, make sure that the production environments are up and running, and they withstand the demand. These are all make sure that the site reliability. They make sure that the product environments and product systems are stable. And a DevOps system administrator. DevOps is these are the guys make sure that they're like a center of excellence. They work with multiple teams in the company, make sure that everything goes smooth, operational wise, DevOps and operational wise. They are the bridge between the development team and operational team. So that is pretty much like DevOps system administrator. And earlier we talked about it, right? Earlier, software companies, they used to have a very large products, software products. Those are called monolithic products. If you have to do any minor change in the software product, they need to be very careful because they don't know what they are really tampering with. If they make a minor change, they might trigger some issues in the big system. So earlier it was like, the whole system was like one banking application. Let us say one banking application. The banking application is a very huge application. If somebody make any minor changes somewhere else, right, it might cause problems somewhere else. So that's why they need to be really, really careful. That is a monolithic. But nowadays in software development, they are encouraging, instead of developing the whole product as a one big or multiple big products, they are encouraging the software product divided into small blocks, like Legos. You want to divide this whole software product as a small blocks, and you can individually assign that work to the individual players instead of encouraging everyone working on a big product. Then we can divide it into the small services and we can say, hey, you work on this product A, I work on the product B, somebody work on the product Z. At the end of the day, we can all integrate all of them A to Z. That's what they do nowadays, instead of taking the whole product as one big product. So what is the advantage of it? When we work on the microservices, see, if you have to do some work on the A, so we don't have to worry about B to Z, because now we can focus on individual block A. But if it is a monolithic, there is no individual blocks. The whole system is one block. So wherever we do any change, wherever you do any change, it might impact the whole system. That's why we need to be really careful, and it's unnecessarily draining of energy. See, for example, if you divide the software product A to Z, then we can assign the work of A on certain small part of our group, small group. We can assign like 3 developers, 4 developers. Hey guys, go ahead and work on this, service A, microservice A, the small block A. And then the rest of the people, they can focus on their work. But if it is a monolithic, right, even though somebody is doing a minor change, then everybody needs to be on alert. Make sure that their change won't cause any problem to the bigger system, banking applications kind of. So that's what monolithic and microservices. Nowadays, pretty much software industry, they are going on the microservices because they're very easy to manage and very easy to maintain. So it is like, so microservices, yeah, you see that, right? Here there is big user interface in a monolithic, and there is a big business logic, data access layer, and a database. See, just 4. But here, if you see that, right, user interface will be multiple microservices, and the multiple microservices behind the scene, they talk to the multiple databases. If I have to change any database change in one of those databases, we don't have to change everyone. Just we have to focus on the particular microservice and that particular database. But in a monolithic, even though we have to do minor change, just we have to put everyone on notice. Got some idea about the
Can you
monolithic?
explain this diagram with an example, please? Like,
Oh, this one, monolithic, huh?
Yeah,
Monolithic
yeah,
and
yeah,
microservices. Monolithic microservices. See, for example, even Facebook, right? Facebook also, see, when we post something, right? When we post something, we are not touching all the functionality. So we are touching, actually, we are working with a we are working on a certain functionality of the whole product microservice, whole product Facebook, right? So we are not worrying about the rest of the things. See, when we post something, just our focus is on just posting the picture. And once you post the picture, and our expectation is it should be posted properly, and that's what our expectations, right? So even the product like a Facebook and almost all the modern software, they work on the microservices level. See, when I post something on the Facebook, rest of the users, they don't have to stop their work. They don't have to look at me. Hey, are you done with your work? So that we can continue our work. They don't have to do that. They keep doing whatever they do, and I do whatever I supposed to do, right? So this is all microservices level, because see, whatever I do, it won't impact them, because though the Facebook applications looks like one application, but it has a lot of individual blocks. So whatever blocks I am playing with, it won't impact other users. So what they did in the designing itself, what they do, they develop the product set in a way, make sure that there won't be much dependencies between the individual blocks. So that is one example I can give on the microservices. But if it is like, if the Facebook is like, let us assume if the Facebook is like a one product, one big product, instead of individual, like millions of individual pieces, right? If it is like one product, then if I do something here, it will impact somebody somewhere else, because we are all using as one product. But if it is like microservices, like small blocks, if I'm playing with my blocks, playing with my Facebook portfolio, and I'm playing there, it won't impact somebody else, because this is all actually there is another technical term called decoupled. Decoupled mean there is there is no coupling, there is no dependencies. Whatever I do here, and whatever somebody is doing here, there is no dependencies here. That's called decoupled. In a microservices model, pretty much the advantage is it's totally impossible to decouple, but pretty much we can decouple at the maximum level, so that my individual actions won't impact somebody else somewhere else. Got some clarity?
yeah, yeah,
Okay,
yeah. Thank you so much. Yeah.
you're welcome, sir.
So, Raviji, I'm sorry to interrupt.
Oh,
Is
yeah,
it
yeah,
like so just the same example, of posting a picture? So posting a picture would be one thing, and then the comments and the likes and all of those would be different. Is that how we understand? Like in e-commerce, I know of e-commerce, like if there's a website, let's say Amazon, you have a search thing would be one thing, and then the ratings and remarks department would be one, the payment would be one. Is that how we understand that?
actually that is a good example. See, that's good actually. What happens, one advantage also I will tell you. Let us think about Amazon terms. Anyway, you brought it up, right? See, um, Amazon, there are like multiple. See, when we go to the Amazon portal, right? So there are multiple functionalities, right? I can search a product, and I can purchase a product, and I can give a rating, and even I can return a product, and even I can buy, online products, audios or whatever it is, right? It's a lot of functionalities. See, for example, pretty much what they do. See, monolithic is a big beast. We understand it. So maintaining is a very difficult, and it consumes everybody's resources, right? So it is not good. We understand, right? But when we divide the microservices, yeah, microservices sounds very exciting, because whatever I do, it won't impact whatever it is, right? Whatever we discussed so far, it looks so good, right? But the problem is how we define, how we decide, how can we divide a big giant monolithic into small parts. That is really important too. So we cannot just like take a big you know kitchen knife, and we cannot make it like a sliced pieces, right? Like we cannot make like 1,000 pieces or whatever it is. So what we do while they are doing the designing itself, like Shraddha, we while doing the designing itself, the designing phase, they will come up with that. Hey, let us make this search option as one individual functionality. Let us make this payment option as an individual functionality. Let us make maybe rating or returning as individual functionality. So the beauty of this one is, one nice morning, if there is some problem with the payment, you know, if the payment is whatever it is, some security attack, whatever it is, right? Payment is not working in Amazon. Good. So at least the payment part is working, not working, but still we can do the searching, because searching has nothing to do with payment. And still they can keep giving the ratings. Ratings may not depending on the payment. So the beauty of microservices is, if there is a problem or if there is a product upgrade of certain service, they don't have to stop the rest of the services. Whole website cannot, you don't have to stop the whole website. That is a monolithic. Monolithic, if you do a minor change also, there will be shortage of website. Like banking sites, right? If you go to the banking sites, they say, oh, the site is down for the maintenance for certain period. There are some changes, right? But if you see a fast-paced website like a Amazon site or Facebook, you you don't hear about it. The site is down until unless something crazy happens, right? But we are talking about day-to-day terms, right? We don't see that because it is a part of a lot of microservices. If one functionality there is some problem, while they are working on it, other parts are still we are fine. We can continue our work. So yeah, as Shraddha said that, right? As of now, let us think about it. The payment is one microservice, search is one microservice, rating is one microservice, returning products, returning labels, printing labels, that is micro product, and buying videos or watching, Amazon Prime is one functionality, something like that, right? So we can think about it. These are all individual microservices. Instead of mixing everything as a one big product, if something goes wrong, instead of closing the whole shop down for certain hours, nowadays it is not at all acceptable, because now the user, um, as we discussed, right? Now the users expect, the what is that expectancy, right? That is really, really, really crazy, because we cannot wait for some site down for hours, right? Very bad ratings. We will see tons of ratings.
Like the patience level, like they easily switch to the another side. Yeah, if
Yeah,
the latency rate is not good. Yeah.
yeah, it's because of the technology where we are in. So
Yes.
now how many people log into the computer to do some purchase? Everyone fingertips at mobile, right?
Right.
So
Right.
if the mobile takes like a sweet 5 minutes or something, how many people go and visit that site again? Definitely I won't do that. I was like, okay, this is a junk site, I don't want to go, right? So immediately we will give a review. So that's what our user our expectations also actually, it's increased. And even the technology whatever is available for us, actually that also caused us to set a higher expectations. And companies are thriving, companies are striving, and they're thriving also based on meeting our expectations. So how can such a small team up to 10 people can self-sufficiently handle all phases in software engineering life cycle from architecture operation? Okay, this is about DevOps actually. He's talking about DevOps. The good DevOps team is a combination of developers, a combination of testing team, a combination of operational team. They may be physically they belong to different teams, but it's like a logical team, like a Scrum team. As a Scrum, we pull few developers, few business analysts, few people from different teams, and we form a Scrum team. And once, as long as the particular sprint is available, right? So everybody works on it, right? That's what they do. But once the sprint is over, everyone go back to their actual original team, right? So in the DevOps world also, developer teams anyway, they have a development manager, they have a development team. That's good. QA team, good. Operational team, like maintaining servers, hardware, network connections, those are good. And business analyst, project manager. But at the work, right? So they all collaborate together as one team. So maybe like a 10 members team. So they are from different parties, but they all together, they work like a collaborative environment. So that's what they are saying, that company has a multiple products, company has a many services. So DevOps, in the DevOps model, on average, like 10 people, they collaborate together. 10 people will collaborate together. How can such a small team up to 10 people can sufficiently handle? So nowadays, the expectation is how many people have heard about a full stack developer? Full stack developer. If you see in the job market, right? It is very, very common expectation, full stack developer. So earlier, few people are like developers, few people are like a QA team, few people do the management kind of thing, right? But nowadays expectations, it is more and more the trends are coming up. They're expecting everybody do development, everybody do the testing, everybody can able to collect the requirement and change the stories and participate in the Scrum meetings without any Scrum master. These are the latest trends actually. So that's what I have been trying to encourage all of you guys to pick up as many concepts as you can, not confined to particular thing, because nowadays software industry expectation is to know, not only particular area of interest, right? So multiple areas. So DevOps suggests us to build a product services, microservices API, small teams up to 10 people. See, microservices are very easy to maintain. Microservices are, well-defined individual blocks. That's why, small team is good enough, because as I told you, right, if there is like A to Z blocks, right, they just focus on the block A or the block B or block C at any given time. They don't have to worry about the whole system A to Z. If they are worrying about the whole system A to Z for every minor change, that is not a microservice, that is a monolithic. But if they can just focus on the block, whatever A they are working on it, that is like microservices. To maintain small microservices, we don't need the whole, what is the whole world, right? For Amazon, if there is a problem with their billing, they don't pull all the engineers. They pull only the people whoever handles or whoever are specialized in this payment mechanism. They only pull those engineers. That is the beauty of microservices. If it is a monolithic, all Amazon workers will start working on only the product only, because until and unless that is done, the whole system is down, right? When the system is down, what the other people will do? So everybody, they will pull everybody. Hey guys, our Amazon system is down. Come on and bring it up, whatever you can do. So that is a lot of chaos. That is not productive at all. If the problem only 10 people can solve the problem, they will bring in 1,000 people into that. That is such a waste of time. That's a lot of technical debt. You are unnecessarily wasting a lot of energy, a lot of your system resources. So that is not a productive way of doing business. This is a clear example. You tell that. See, minor problem, you pull 1,000 employees to solve the issue. That is a monolithic. But if you divide this system into small microservice level, you bring 10 people to solve that minor issue, while the rest of the people can work on the rest of the products and the rest of the customers can enjoy the rest of the microservices. That is the beauty of microservices.
So these microservices for me looks like the story, like what you said, from the product backlog we take the
Scrum
particular
backlog.
story. Yeah,
Scrum backlog.
Scrum
Yeah.
backlog we built
Yeah.
up. Yeah.
Yeah.
So
Yeah.
from the developer point of view, this is structure is like that, microservices.
Yeah. So yeah, the Scrum actually, that is a good example too. So what they will do, right? When you discuss with the product and the product owner talks to the stakeholder will tell that. See, for example, I'll give a good example. Let us assume that Amazon is not there. Amazon product is there. Actually, we are developing the Amazon product. Let us see. So then we are developing the Amazon website for the Amazon. So Amazon is the stakeholder client, and we are the company, software company, right? We are all one company, guys, right? So our product owner will go and talk to the Amazon guys. Okay, there is no system at all. First of all, what do you want us to do? You want us to bring in a search functionality or a payment functionality or on a rating functionality. So they will think about it. Now we need to sell our products. First of all, bring up the selling functionality, right? Who worries about rating? Rating these things, they can stay a little longer, right? First, money transactions are important, right? So definitely the stakeholder or Amazon will tell us, hey, we need to sell our products immediately. Once we have the revenue, we can do like 100, we can do like 100 feeds. First I need the money. That's what he will ask us. Okay, in your first sprint, go ahead and develop a website for me. The website should able to handle the online purchases and online transactions, right? So the sprint one, okay, we develop a Amazon website and with minimal functionality, like the payment functionality. Then they will deliver to the customer, and the customer start working on it. Customer start using that website, and then next Amazon guys again come back. Hey guys, good job. For the next spring, let's go ahead and put additional functionality, like watching videos or maybe streaming the videos online. Let us add that. So they will come back and they will tell us what they want. We are like, no, 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 we will develop this one and you take it. That's not going to work out, right? Because those are the people sponsoring our program, so they're paying us, so we have to listen to them. So they'll say that, no, no, you guys go ahead and put the video streaming. Fine, we will go and we will follow the Scrum and develop the product. And then after acceptance, right, the stakeholder will say that, hey guys, good, you deliver this product. Or if he's not happy, you will tell them, no, no, it doesn't meet our requirement, whatever we agreed for that. Everything is well documented so that he cannot bluff and those people cannot bluff. So there is a check mark, right? Whatever they agreed for, whatever they delivered it, right? So that's what good. So next they are one, then they come back with next functionality, on and on and on, until one day Amazon will say that, hey guys, enough work, we cannot spend any money on that, and we are pretty happy with whatever we have it. If you have the new requirements, if you see the new requirement based on the new functionalities, we'll come back to you. As of now, you can take a break. Then what will we do? We will dismantle our Scrum team and everyone go back to their other project. So we are the software company, right? We keep working on a lot of projects. Not only Amazon, we can, if Amazon has other work, we will work with Amazon. If Amazon does not have a work, we will work with Walmart product or some other target products, right? That's what we do. Clear? Did I confuse you guys more?
No,
Clear?
it's clear.
It's
Yeah.
good. Good. Thanks. That's what I'm asking you guys. It's a collaborative. See, we're all learning, to give you class. Actually, I spent 3 hours to prepare, while I went through this 100 pages book and I did some research on the online to bring some of this architecture diagram. So it's all collaborative. So come, you guys also do a diligent, search on it so that, we can have a better discussion and dialogue, right? Good. So next one is Kanban board. Yeah. So pretty much, like our Scrum, these are all related. Scrum, DevOps, and we are all, we use the same kind of mechanism, right? So if you see that, right, they use the Kanban boards, they use a lot of dashboards, and they use pretty much they use the same kind of tools like Jira, Jenkins, GitHub, Confluence. These are all tools. Actually, we will talk about tools a little bit later point of it. Here also same thing. So what is the backlog? What is the selected? What we are, I'm sorry, what we are working on it, what is the testing done, where we are with the testing. So these are all like designing board, developing board, operational board. So this is all like Kanban board is not like a physical board. In the Jira, actually we have something called dashboards. When we go there pictorially, we can see that where we are, what we are doing, what is the status, everything. Like you guys did the Scrum training, right? We did the drag and drop. That is a Kanban board kind of. Initially we have the initial what is that initial stage, you have all the tasks, then it's a progress, then it's a done. You got it, right? So the hands-on lab, that is pretty much like a Kanban board. Okay, now we talk about the tools, for the continuous integration, for the code, code integration, we use the Bitbucket, GitHub, and code management, we use GitHub. And for the build is nothing but when we develop any code like Java, Python, those are all language. There we need to have somebody who can interpret those languages and package all of them. That is called building. So for the build we use the Maven, we have this Gradle, Apache, microservices. Again, for the microservices management, we have micro Kubernetes, Docker. Okay, go through them. There are a lot of tons of tools in the market. So we are not going to talk about tools, but just like few examples, like for the DevOps tools. These are the commonly used DevOps tools. So configuration management, we
Thank
have
you
it.
for showing this chart to us. Actually, if you will see the job requirement nowadays, I am sure like they are asking some 10 to 12 tools out of this. I didn't have any idea. At least by seeing this chart, I can find out, okay, oh, this tool is used for this. Okay, okay.
Yeah, yeah,
Like
yeah,
especially I've seen this GitHub, Git,
yeah.
Maven. I have seen this name, but I didn't know.
Right. In the workplace also, see, continuous integration. Even in my previous workplace, we used to use GitHub and Jenkins, Selenium also for the testing. For the testing automation, right? Code management, we use the Bitbucket and GitHub. But I did not SonarQube. I use it. Xcode, I did not use it. See, we don't have to know all the tools, right? Just at least if you know like one tool each, that should be great. Just like half an hour YouTube video, if you watch it right, you will get some good idea about it. See, monitoring is like, if there is any code error, if there are any errors, if there are any websites, if there are spikes in the website, depends on the, so who raised the hand? Sushma. Yeah, Sushma, I want to ask something.
Yeah, Ravi.
Yeah.
So basically, this DevOps and Scrum both are agile, right? Agile methodologies.
Yeah, Scrum is agile. Agile is like agile is nothing but being flexible, right? So instead
Uh-huh.
of this monolithic or the old waterfall, all these frameworks are actually pretty much, they encourage
Micro.
much degree
Mhm.
of collaboration and a micro level, instead of dealing
Yes.
with a big beast at one point, divide and conquer, right? Kind of thing actually. Yeah, there are pretty
So
similarities. You see a lot of similarities. Yeah.
yeah, so basically, what is the difference between Scrum and DevOps? Like DevOps deals with two different departments like development and operations, and Scrum uh, deals with the whole process of um, the life cycle. Is it like that? What is the basic difference between both of them?
Yeah, we talk about microservices, right? Individual microservices development, that is individual microservices development, that is pretty much like a Scrum. But if you see the DevOps, maintaining the whole microservices, maintaining all the microservices, maintaining the whole application as a one whole, that is like a DevOps. In a company at any given time, there may be like a 5 to 10 individual Scrum meetings, depends on multiple products. But in any given company, there may be one DevOps team which can handle all those Scrums actually. So DevOps is pretty much like a center of excellence. They are like a center point, integrated point. They deal with multiple parties in the organization. That is like a DevOps. Scrum is like, Scrum is a process which they use to develop a software product. If there are microservices, there are like multiple microservices, right? One Scrum team focusing on one, another Scrum team focusing on another microservices, or maybe a set of microservices like that. That is a individual Scrum meetings. But at the end of the day, they might use the same DevOps tools or the same DevOps methodology. See, whatever Scrum they follow, right? But either company has like one instance. Generally, most of the companies, they have one instance of GitHub. So everybody, what if there are like 10 Scrums going on? Still, everybody uses the same GitHub instance to integrate their code integration. And most of the companies, they have like only one Jenkins instance. Whatever, if there are like one Scrum or 10 Scrums, they use the same Jenkins instance. Similarly, the Docker instance and Ansible scripts. These are all like a common services actually. So DevOps is like a little bit bigger picture. It's like corporate wide. It's a corporate wide. It's overall interaction with the operational team, overall interaction with the development team, and the BA and the rest of the teams. Scrum is like a small Scrum is like a small subset of it.
Yeah,
Company
small unit, small subject subset of the
subset
whole
of,
big picture.
yeah.
Uh,
Scrum actually,
okay.
most of the Scrum team, most of the time Scrum team is a Scrum master, product owner, a developer, a QA, or business analyst. That's a operational won't come there.
Yes. Yeah,
In, in,
that's
Sc-
right.
in Scrum, operational won't come there. DevOps
Mm.
is a big picture, whole corporate wide, all the development teams, all the operational teams, everybody should follow this DevOps framework. So you see the DevOps as like a one corporate wide, bigger picture. Scrum is like, small individual parts.
Okay. So a DevOps team can have multiple Scrum masters or project managers,
Yeah,
right?
DevOps team, generally what happened, I was a DevOps manager in my previous job. So what we do, we have like a 10 members team. But even though we are a 10 members team, we work with the development team, 100 plus development team. We work with the operational team. There is another 25 plus operational team. So there are business managers, business analysts. We used to work with them. So how we do that? So if we work on like a one-on-one, right? It's not like a combat, right? One-on-one, that's difficult. What we do, we have all the tools. We set up all the tools, automatic tools. So even though those are like 100 developers, when they check on the code, the system automatically takes care of it. Whenever there is an issue, they will open a ticket, then we will take a look at it. So because most of the DevOps tools, they integrate at the corporate wide. So that's why DevOps is like a bigger picture. We're talking about this whole organization, DevOps.
Okay.
Yeah, Scrum is like a
Thank
small,
you.
small individual level. Yeah, clear?
Yeah, sorry for interrupting.
No, 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 no. That's good. This is our class. Come on.
Sure, thank you.
You're welcome. So generally, there are some principles for the DevOps. Code and check into trunk. So it's like I told you, right? Continuous integration. Whenever you check in the code, you check into the main trunk. So trunk is like a main code. All the cumulative code actually. If something goes wrong, we can always cut a branch out of the trunk. So build deployable packages and validate deployable packages, dependencies, and configuration readiness. So all these 10 points you see them. So these are the common principles of the DevOps. What we do, we have to follow the certain guidelines, make sure that we will, we deliver a good product. So, and there is another concept called blue-green deployments. So blue-green deployments are like, almost all the environments, they have like a carbon copy of other environment. When the particular release is very good at one environment, for example, say green, when it is good, what they will do, they will start using that environment. There's like a load balancers actually. There is a different concept called load balancers. I will discuss some other day, but I will give you like a brief example. See, Amazon or any website, right? It won't run on one server. They will run on multiple servers, not on one server, multiple servers. So what they do, how they, but we don't know that. When we open a Amazon website, right? Just we will go to the website, we will do the purchase, we'll come back, right? We don't know. But behind the scene, they have like tons of servers together. They provide that functionality. So what they do to maintain all those servers, to properly balance the load, user balance, what they do, they share the load between their servers. They internally, they work on it. We don't know those details. Those are called load balancers. So what happened if the Amazon has a 30 servers behind the scene, which handle our website. As a user, we go there, we do the purchase, right? So for example, out of those 30 services, the 30 servers, 2 servers are not working that day. I mean, there are some problem or there are some maintenance. So what they will do, right? They will disconnect those 2 servers to handle our load. So that rest of 28 servers, they will take care of our load. So we don't see the difference actually, because that is the duty of the load balancer. If there is something, a server is down, so immediately it will load, it will redirect the load to the different servers. So what happened, for example, Amazon has a 30 servers. When we are doing, we are using the web services, right? So for example, 1 to 15 and 16 to 30, right? So they have to upgrade something. So they don't have to bring all the Amazon web services down. That is the beauty of the load balancer. That is the beauty of having multiple servers. So what they will do, they will redirect the business from server 1 to 15, which can handle our workload. So 1 to 15 servers will take care of our business. They will disconnect the remaining 16 to 30 servers to handle the business. The 16 to 30 servers, they will do the upgrades. They will do whatever patches, whatever it is. And once they are ready, right? If they have to do the 1 to 15 initial taking care of business, then they work on 16 to 30 upgrade. 16 to 30 are good. So what they will do, now they will route the business to 16 to 30. Then they will disconnect this. First, they will route the business to 16 to 30 because the servers are already ready. So without any interruption, immediately, our business will be, our business will continue as it is. So then 1 to 15 servers are ready for any upgrades. So generally what they do, if their business can take 4 servers can take care of it, right? Generally they will maintain equal number of more servers actually, because if there are anything happens, right? If anything happen, if they have to do maintenance, anything else, right? So what they will do, so they can direct the business to the rest of the servers, and they can work on multiple servers. They can work on remaining servers. So that is the beauty here. That's why he gave like a color code actually. One is like a blue, second one is green. When the blue servers are ready, then you move the business to the blue servers. When the green servers are ready, you move the business to the green servers, so that you have 2 sets of servers, If you have to, if you have to do any maintenance or something, that's very easy. And the CI/CD pipeline. Yeah. Team, can we take like a 5 minutes break? Then we can continue. Okay. I should not be having too many slides. Okay. I will wind it up. Okay. Give me 5 minutes. That's all.
Mhm.
Break. I will grab a cup of water.
Sure, sure.
Thank you. Welcome back. So CI/CD pipeline, right? Continuous integration and continuous deployment. Can you
Yes.
guys hear me? Are you good? Everyone good?
Yes, we are good.
Okay, okay, good.
Good.
Okay, yeah, there are just a few more slides. Okay, then we should be all set. Okay, CI/CD pipeline, right? So CI/CD pipeline is like it's a what is that? Jenkins build. It's like a continuous integration, continuous deployment process concept actually. So what we do, right? In general, when developer develop a code, once he is done with the development, right? What does he do? He checks in the code, right? When he checks the code, so that is called integration, right? His code will integrate with the rest of the developer's code. Then it will automatically, there will be a build because the Java or Python or any language, right? So the code should be compiled. It is almost like, spell check. It is like a correction. So once it is done, it will be bundled together a package. The package is called artifact. The artifact can be jar, var, or ER file, jar file, var file, or ER file actually. So once it is done, they will do the testing, and once it is good, and when everything is good, then they will deploy to the they won't deploy to the production directly. I mean, once the testing is everything is over, they deploy to the staging. Staging is pretty similar to the production, but it is a server. It is a server before the production environment. So staging environment pretty much simulates a production environment. Before they do the actual deployment, they deploy to the staging, make sure that it fits well on the production. So almost all the applications, they won't deploy to the production. First, they will deploy to the staging. It's a staging to the production. So it's pretty much mimic the production environment. So this is the pipeline actually stages. I think one of our slides, they have the similar one. We went through some of the stages. It has it actually. So deployment, production, notifier, and test. Yeah. Yeah, this is pretty much, yeah. Coding, building, test, package, release, operate, monitor. Yeah, pretty much it. This is the one. So same thing, it is in the sequential order here. So CI/CD pipeline, commit code, trigger build, the build, notify the build is completed. Then the run test cases. Nowadays, how they're doing, right? The test cases, instead of the manual testing, they're writing the test cases in a test cases using a language called Selenium. So what they do, the test cases will be, they call like a test scripts, right? So whenever the deployment is over, the test scripts automatically triggers, and we don't need anyone's intervention. What they will do, they will run all the test scripts, and based on that, right, they will write it down all the test results. By next morning, when somebody starts this build, it runs. So next day or whenever it is, right, so they can go through all the test script summary, and they can come to the conclusion if anywhere it is failing or anywhere is passing. So almost like, nowadays the testing is pretty much like a automatic. So using the Selenium scripts, actually we can play around with that. So once the testing is completed, then they deliver the build to the staging, then finally it's to the production. These are the pretty, typical CI/CD pipeline. It is not in the book actually. It's just I grab it, just for info. So same thing, coding, and then go to the building, unit testing, store artifacts. um, Store artifacts. Again, artifacts are like a jar, var, er file. So get the artifacts and deploy it and test it. Version, manual deployment to the production, auto deploy to the production. So deployments are two types actually. Deployments sometimes, like what is that? Amazon or Facebook. They won't wait for somebody's approval. I mean, either YouTube. I mean, there may be some automation scripts, they will see that, if the content is appropriate or not, right? So if it is the content is legit, they check it, that they have auto checks there, but there is no manual intervention. Nobody sits around there and they won't wait for me. Oh, what is Ravi is posting today? Nobody is waiting on me, right? When I post something, they have a filter. That's an automatic filter. If my posting, whatever I posted, right, if it pass those filters, it automatically be, what is that, published, and it will be, the changes will reflect, right? But if whatever I post it, if it doesn't meet, if it doesn't, if I fail their criteria, right, if they put some of their criteria, right, if I hit it, right, then they will like, we cannot post this content, kind of thing, right? Especially on YouTube, we see that. So that is example. So there is like a manual intervention. Some is like we don't need a manual intervention. It's like automatic. so we can automatically deploy it actually. So again, yes, Sushma, you asked this question, right? Here, see, Agile. Oh yeah, this is a good slide actually.
Mhm.
Yeah, see what is Agile and Scrum? Agile and Scrum, those are like, we use those words interchangeably. So focus on the process, highlighting change while accelerating delivery. It's like, pretty much like, it's just process, change, delivery. And what is DevOps? DevOps is focus on culture. So you bring the cultural change, whole organization, development side, operational side, business analyst, you bring everyone. Is like it's a whole cultural change, like the whole organization. Highlights the roles that emphasizes responsiveness. So they're like a multiple parties. So DevOps brings everyone on board, right? So everybody, we assume that everybody does their roles response, responsibly. But in the meantime, they collaborate very well. That is the expectation of the DevOps. Scrum is like process, overall process, and it's a change delivery. If there are frequent changes and there are multiple Scrum calls and there is a mechanism of delivery and there are process, one company can have like a multiple Scrum calls. And CACD is focused on software defined lifecycle tools. So CACD is like a continuous integration. When you talk about continuous integration, what is continuous integration? Code or any configuration changes. Pretty much like a continuous integration is, it's like a development oriented, software defined lifecycle. It's pretty much like software development, software deployment, software development, software deployment, CACD. But DevOps is like a whole cultural shift actually. You bring all the parties together, DevOps, dev teams, operation team. Nowadays, there is another concept called DevSecOps, development, security, and operational. Because nowadays security is like really cornerstone of many organizations, considering there are a lot of security threats in the, nowadays, right? So that's what. So do you think it will be helpful? There is a little comparison of Agile, CI/CD, DevOps, right? Yes, no?
Yeah.
Okay,
Yes. Thank
you're,
you.
you're welcome. So categorization of DevOps tool chain. There are a lot of tools, right? So for planning, we use GitHub and Jira because Jira tickets. And if any one of you guys have any idea about Jira, there is like, it's a ticketing system is where we can put the requirements and where we can maintain the backlogs, product backlogs, Scrum planning. All these things go for the Jira. For software builds, we use for anything build. Nowadays, we are using Docker or Ansible. Or the deployment, we use the Jenkins and again Jira because Jira has a ticketing system. For coding, we use like a Stash and it's like a GitHub actually. So there is a testing, we use like Selenium. SE is like Selenium, JUnit is for the performance testing. So we will talk about it later when we hit the testing module. Monitoring, we use the Splunk and Slack is for the communication, Datadog is for the monitoring. So nowadays, especially when we are using the cloud environment, we need to monitor continuously, because by accidentally somebody trigger anything, if it consumes too much system power, so the cloud companies like AWS or Azure, they will send us a very big bill. So just we need to make sure that our usage is under limits, under our budget. So that's why we have to continuously monitor, not only for the budgeting purpose, but also for the security threats. If any service is down or something, immediately, I have my mobile, I have a something called Pager Duty. Pager Duty, it was integrated. It was integrated to, yeah, Pager Duty was integrated to Jira system. And Jira system was integrated with the Splunk. There is a Splunk system. So if there is something happen, so the ticket automatically enters into the Jira will trigger the call into the PagerDuty. I will get a call in the PagerDuty. So most of the systems are like now, it's like a automatic monitoring when something happens, and we will get an alert automatic. Nobody has to sit down in front of the computer and keep looking, staring at them. So that's the beauty. Nowadays, there are a lot of tools available in the market. So those are pretty much automated tool, and they will do all the job for you guys. So this is not needed. And continuous integration. There is a planning, delivery, testing, deployment, and deployment operations. Like another development, DevOps, right? Development, operations, and security. This is like a DevSecOps, development, security, and operations. DevSecOps. Kind of pipeline. What is pipeline? pipelines are like, you commit the code, there will be build process, there will be testing process, there is a deployment to the staging, there is a deployment to the final product deployment. So this is called pretty much like a pipeline. We use a tool called Jenkins pretty much for it. For the code integration, we use a tool called Git. And when the code commit into the Git automatically, there is a plugin. Plugin mean there is like a event handler, something happen here. So we set a condition. When there is a code commit here in the Git, and Jenkins automatically triggers a build, and it will deploy the artifact. Artifact, I told you, right? It's a package, and the code will be compiled, corrected, whatever it is, right? It will package all of them, and artifacts is ready. Artifacts will be deployed to the staging. Once everything is good, and it will be deployed to the production. Hey guys, these are not in the book actually. I grabbed these slides from different channels. Go through them, and if you have any question, feel free to hit me. So pipeline look like really pipeline, right? But in the real time, it won't be like that. Real time, it will be like this. So this is a pipeline. So why they use the word pipeline? You see that, right? Stage to stage, get release, build Docker, upload Docker, deploy, smoke test. So after that, there will be deployment to the staging, and finally there is a deployment to production. You see that, right? Left to right, it's like a pipeline, stage by stage, 1, 2, 3, 4, 5, like right. So here also stage by stage, commit, build, test, stage, deployment. So that's called it as pipeline. So same concept, and top development tools as we discussed: Splunk for monitoring, and Prometheus, Jenkins for the deployment, and Docker for the operate, and monitoring Nagios test. So there are like different tools actually. So we already discussed it actually on the top of it. So development, a DevOps tool. There are tons of DevOps tools are available in the market. So a typical DevOps tool should do a developer centric job, a cloud ready. It should be ready to adapt to the cloud, CI/CD compatibility, easy to integrate. See, as I told you, right, DevOps itself. The process is like integration of different, interesting, different parties in the company. Similarly, the DevOps tools also should be ready to be integrated. As I told you, right, when we have a Jira integration with PagerDuty, if there is something happens in the company in the Jira, we will be getting an alert to the PagerDuty. Obviously, there is an integration between Jira and PagerDuty. And many companies, they use Confluence and Jira. Confluence is for the documentation purpose. Jira is for the maintaining our backlogs and monitoring our tickets. So there is integration between Jira and Confluence. So nowadays, the software tools, there is integration. We don't have to monitor that. If something goes wrong somewhere else, automatically we will be notified somewhere else. That means that there is a lot of integration in between. So again, DevOps, you bring the development world, operational world, QA, DevSecOps, even you bring the security world all together. So DevOps is pretty much like a center of excellence. They interact with every party, and he facilitate a smooth operation of the company. So this is pretty much, I took good number of concepts from the book, and I added a little bit more on top of it. Go through them, and if you have any question, let me know. Any question?
Yeah, I do have.
Yeah, sure, Sushma, please.
Yeah. Can you go to that 28th slide? Yeah, when you said each phase of the development
DevOps.
activities, yeah, that are involved in DevOps, this mentions one, what is that? The Jenkins or Splunk. Do we need to know one per each phase of the development cycle, or how is it like? Do we need to learn all these?
No. We don't have to. Even I don't know all of them. So the thing is, see, in this class, in our class in particular, we don't have to know any one of those tools. In this class, we are talking about it, a framework. Framework is like, a complete process, how to end to end what works actually. So nowadays, there are a lot of tools for the coding. There are like hundreds of tools. So for everything, there are a lot of tools. If you see that, right?
Yeah, that's what you showed in the previous slides.
Here it is. Yeah.
Yeah.
And Soumya is so happy to see all the tools in one plan.
Yeah, me too. So Do we need to have one on
Mhm.
each level?
I like this slide.
Depends on what kind of job we do. See, when we are a
Okay.
DevOps engineer,
Yeah.
general expectation is to know something about Jenkins, because Jenkins or Spinnaker,
Uh-huh.
these are the two tools we use very widely. We use them in the job market. And when we are a
Yeah.
developer, even people expect a good amount of idea on the GitHub actually. So when somebody is a
Okay.
developer, right, when they develop the code locally on a platform called IDE, Integrated Development Environment, they're supposed to check in their code. They check in their
Mhm.
code to where? They have to check in the code to CI, continuous integration tool, a continuous integration tool
CI/CD.
like CI tool, right? Continuous integration tool like GitHub. So that's why
Mhm.
it is expected they know the GitHub. So or Bitbucket. Bitbucket also similar kind of actually. When we do the build, we expected to know one of these. And
Okay. Can you give the list of things that, like, the things that we need to basically have as a DevOps, um, uh, if I'm looking for a DevOps position?
yeah, again I'm telling you, right? So now the DevOps is like a really big uh, big integration.
Uh-huh.
So there is actually it's all about a DevOps framework. The framework covers a collaboration between development team, operational team, and QA team and security team. There is no
Mhm.
person who knows all the tools. Not everybody uses. There is no possibility, right? One person knows all
Right.
the tools. He cannot know. I mean, there may be some exceptions here and there, but in general, right? Nobody knows all the development tool. Nobody knows all the QA tools, operational tools, security tools. It's a highly difficult. So that's why if we want to apply like a DevOps engineer, right? Then the
Mhm.
expectations are like knowing like Jenkins, GitHub, and some cloud concept, some monitoring, and a
Okay.
Slack, this kind of. So wow, okay. For your question,
Just
right? Maybe knowing
uh,
like a one tool each. For
one tool
example,
on each place.
continuous integration. Let's make it simple, right? So continuous
Yeah.
integration, GitHub or code management, maybe in code management, same thing actually. GitHub again, we
Yeah.
can use the
GitHub.
GitHub.
Yes.
Yeah, microservices. People use different tools to microservices, and nowadays Kubernetes. If somebody knows Kubernetes, they're in high demand actually. Very few people have Kubernetes knowledge. And JMeter is for the performance testing.
Selenium.
Selenium
Yeah.
is for the automation
Mhm.
testing, and the security testing. Wireshark people are using that too. And configuration
Okay.
management they use like a chef. So if people if good thing is, see, if somebody is good at one tool, right? So to work with the rest of the tools is not that much difficult. I
Right.
never I
Okay.
never work on I never work on um, yeah, I never work on Bitbucket, but in my organization, previous organization, we have Bitbucket. But I navigate to Bitbucket. I was like, oh yeah, there are a lot of similarities between Bitbucket and GitHub. I can give a comparison between the tool what I know, the tool what I supposed to work.
Okay. Basically, building on the foundation that we have,
Yeah,
just
yeah,
building our knowledge upon that. Okay.
yeah, yeah,
Thank
yeah,
you.
yeah. This class is pretty much my intention for all of you guys. Know that there is a concept called DevOps. So what is DevOps? DevOps is pretty much like a cultural. Know that there are like multiple components of the DevOps, and what are the buzzwords like CI/CD? What is CI/CD? What is artifacts? And what is a pipeline? To give you an overall idea, to give you an overall architecture. But if you really want, if any one of you guys really want to hit any one of those jobs, right? We can have like one-on-one discussion. I will tell that, oh, you guys want to try this operational side, pretty much have a good idea, good knowledge on the cloud, or maybe like one of the build tool or something. Yeah, there are a lot of tools. Even there are a lot of improvement on these tools too. They're like, it's like a continuous process, Sushma.
Sure. Thank you, Ravi.
You're welcome.
So I want to ask something like here in the cloud platform, we can see this Azure, Google Clouds. So I heard about these two. So I'm just asking about this too. Like Azure itself is a big thing, right? So we have so many job openings on a simple tool on this one particular tool itself, right?
Hmm.
So same way for the others also.
Yeah,
That is
yeah.
others seems to like a package to me, like.
Yeah, I will explain. See, the thing is, see, this Azure or AWS, right? Azure or AWS, they not only stop with a cloud providers. They they not only provide with just providing cloud infrastructure. So what they do, right? They have hundreds of tools. They have a code integration tool, they have a building tool, they have a deployment tool, they have security tools. So they come up with a lot of tools. And not only that, not only Azure or AWS, many third-party vendors, so they develop a lot of products specific to Azure or specific to AWS. They do that actually. But what happened in the market sometimes, if you purchase all of them from Azure, so Azure, I want your servers, I want to use our services, the build service or security service, whatever it is, right? If you package all of them, sometimes it is so expensive. And sometimes some of the third party tools, which might work more, effectively than the Azure itself. So whatever Azure sells or AWS sells as a package, right? But some of their features, some of the tools available in the market, they outperform these, the bundled package. That's why most of the corporations, what they do, sometimes they purchase the servers anyway. We have to use the cloud servers, right? They use it, but what they do, they take the third party support actually, because third party services offer better functionality. And one flexibility with the third party tools are, there is not much control. See, Azure, we cannot dictate them. Azure, oh, this is not working, so do it. We cannot ask them. So we have to wait until Azure comes again with another deployment or another upgrade. But third parties, actually third party individual tools, right? They keep upgrading time to time. Every time they keep upgrading. But Azure kind of, if you buy like a whole package of products from Azure or AWS, we have to wait for their timelines. Their timelines are generally slow, because whatever they deploy it, right? Whenever they come up with a new product, they have to consider multiple factors, because they have to make sure that their overall platform is stable and other products are working. They are not breaking anything. It's again like a monolithic product. But if you buy like individual products, right, third party, so you pick and choose like individual products, they are up to date, up to mark. Questions?
Thank you so much. Sorry for asking. I'm just asking this unstructured question. I was
No,
little
no worries, no
confused.
worries. No worries, no worries, no worries. Yeah. Sri, you have any question?
No, I'm good. Yeah, I feel like you have covered everything like at the high level, architectural level. That's what I felt.
Yeah, that is a
I
DevOps.
like this slide. Yeah.
Yeah. Team, any questions?
Brother Ravi,
Hmm.
Jarushek.
Yeah.
Yeah, I was looking at DevOps video. They were saying like, to become an engineer of DevOps,
Yeah.
you had to learn Python. Is it true?
No,
Programming?
not necessarily. Not necessarily. For DevOps engineer, pretty much Jenkins is needed. Jenkins or Spinnaker, that is needed. But in the Jenkins pipeline, actually, when we do the pipeline, right? Yeah. I mean, I will explain why they said Python. So when we do the Jenkins pipeline, behind the scene, generally we can automate it by writing a script. Script is nothing but a programming, a what is that, a part, a program actually, a piece of program, set of commands, right? That is called script. In general, Jenkins, we use a programming language called Groovy. We use the Groovy, and we can write the script. That's what we can do. We can automate it actually, the process basically. So the same automation we can do using other scripting languages also. Python has a different flavor. Python has a scripting flavor also there. So that's why I think they might say that we can use, DevOps engineers supposed to learn Python, because maybe they use that in that, what is that, context. They might use that in that context, because, whenever we use this DevOps engineer automation process, we need an help of scripting language. Most widely used scripting language Groovy, but it can be achieved through Python. So that's why they might come up with that, that way.
Okay, thank you, brother.
Yeah, but one scripting language, anything, whether it is Python. That's why most of the interviews they will ask that, hey, do you know any scripting language? So then whoever is comfortable, they come up with that. Oh, I'm Python or I'm Groovy or whatever. Yeah, or Ruby on Rail. There are like different scripting languages.
Okay, thank you.
You're welcome. Anything else? So this is just a framework. I will share this, PPT. I'm going to do like this. I will collect some info from outside, not only covering from the book, because book anyway you guys can read it, right? So I try to capture as many diagrams, architecture diagrams, because that explains better actually. Anyway, when we read the theory, we can go through that. Yeah. So I believe pretty much this covers good part of it. But if you miss anything, hit me, okay? So we can discuss it. Yeah, these are good actually, 7 benefits. And hey guys, one more thing I want to tell you, that there is a certification on this DevOps, but as of now that is $150. The certification is like a DevOps architect. But again, I'm telling that this is not a standard certification. That is from the the Switzerland based company. So they are offering that, but I'm going to negotiate with them. I'm going to ask them, 150 is too much, but I paid 150 to get my certification like 2 years ago, 2 years or 3 years ago. But as we have, now we are not alone, right? We have good number of people, so we can discuss with them. But I will come back to you, but don't give the exam until I tell you, because 150 is a lot. So I will check with them and try to get it down, so that you can do your individual. You don't have to go through me like you guys did the PM. You can go individually, do the registration, but I will try to get a code for it, so that it will slash it down. Okay. Yeah, just as of now, go through this PPT, go through the book, 100 pages book, read it. So meanwhile, I will negotiate. I will do my part. Okay. Next class, I'm planning to teach Six Sigma. Six Sigma also, like like a Scrum or Lean Scrum or a Scaled Scrum. That is also a framework. Pretty much, people use it at the workplace. That is all framework. Framework is like different framework. Always think like framework is not a technology. Framework is like a set of rules, set of agreements between all the parties concerned. That is a framework. But when we use the tools, there are tons of tools in the market. Like a Jira, there are a lot of tools actually. Rally is another tool. Like a Confluence, we have SharePoint also. We can use pretty same functionality. Like the Slack is for the communication. We have Teams. So there are a lot of tons of tools, and there are a lot of competitors. And every year they're coming with new features. Yep. Good.
Yeah,
Yes.
that was really good. Thank
Yes.
you.
Yeah. Thank you, Anna.
It's been very helpful.
Yeah, go through this book. See, whatever job we apply, whether we apply PM, BA, or Scrum Master, development, I keep repeating the same sentence. So whatever apply, right? But nowadays market expectations are, we should know, at least, we don't have to be expert in every field. It's not possible, right? But we should know what is going on in the market. So these are the buzzwords. So when you showcase them on your resume, it will really add a lot of value, trust me. Because I see a lot of tons of resumes in the market. Not many resumes they have this kind of skill set. That's why when I designed this program, I came up with certain strategy. Not like it's not like we are not going in a random direction. We are going in a very specific direction, given considering our limited time, and our learning curve, right? So I'm taking in a certain way, so that all these things will add value on the resume. Okay.
Thank you.
Okay.
Yeah, okay.
Okay. Good night, guys. Thank you so much. And if
Thank
you
you.
have any
Thank you so
questions,
much.
feel free to hit me. And Swarna Garu, thank you. Thanks for the class. I hope you enjoy the class.
Thank you, Andy.
Yeah.
Learned a lot today.
And who is new to this class, other than Swarna?
Free.
Thank you very much, brother.
Welcome, Ratali. Welcome. Yeah. Anytime.
Thank you, Ravi.
Thank
Are you
you.
going to
Thank
send
you,
me
brother.
recording?
Yeah. Welcome.
Thank
Andy.
you, brother. Thank you.
Yeah,
Good
welcome.
night.
Thank you, Andy.
Good night.
Good night.
Thank you,
Thank you,
Anna.
Ravi
Good
ji, for
night.
putting so much effort. I really appreciate it. It's really, really like I know but this session was really heavy for me, but you explained it in a very good manner, and that too, like you are putting so much effort. I really appreciate it. Thank you so much.
Oh, my pleasure, Soumya. My pleasure. Thank you.
Thank
Thanks for the wonderful questions. I encourage each and everyone do some groundwork. Come up with more questions or more topics. See, even though we don't know, right? We all can collaboratively do some research on it, and it's like a win and win for all of us. Okay.
Sure.
Yeah. While preparing for these slides, actually, it helped me also. To precipitate whatever I know, and so that's good. Okay.
So yeah, thank you so much. Have a good weekend.
Thank you all.
I
Yeah.
think yeah, tomorrow is Friday. Okay.
Thank you, Andy. Yeah.
Yeah, thank you.
Thanks, Ravi.
Yeah.
That
Yeah.
was so
Welcome.
nice.
Welcome, Shishma.
Yeah.
Thank you,
Yeah.
Anna.
Bye. Good night.
Congrats, Ratali.
Thank
Vindhya,
you. Thank you, Anna.
you are the rock star today.
Thank you, Anna. Bye, Anna. Good night.
Bye, Nana.